everyone, today we are going to look at secure authentication and authorization system built using OAuth2, JWT, RBAC and Keycloak. We'll explore how identity flows from client login through token generation, validation, access control, and service to service communication, all within a scalable multi-tenant microservices architecture. Here we begin with the client application. This is typically a React, Angular or mobile front end where the user interacts with our system. The first step is initiating a login request, which redirects the user to our identity provider Keycloak for authentication. Keycloak acts as the identity provider. It manages authentication using OAuth2, supports SAML, LDAP, or social logins, and is multi-tenant aware. When a user logs in, Keycloak authenticates them, then generates an access token JWT that contains claims like user ID, roles, tenant ID, and permissions. Here we can see that the user submitting the login credentials either through a hosted login page or through SSO providers federated with Keycloak. Upon successful authentication, Keycloak issues an access token and refresh token paired to the client. The JWT token is central to our architecture. It's signed, tamper-proof, and self-contained, meaning no additional server calls are required. To validate it, unless we implement introspection or revocation, it enables stateless authentication and is passed with every request to prove the user's identity. Here we see the token store or revocation list, which captures the revoked tokens for logout, handles refresh token lifecycle, and allows real-time access control invalidation. This component helps us invalidate tokens when needed. Say on user logout or rule changes, when we can use Redis or a shared cache to maintain a token revocation list that's consulted by our API layer or middleware before accepting a token. When the user's session expires, the client uses the refresh token to obtain a new access token. Logout operations also update the revocation store, invalidating the active session token to ensure immediate deauthentication across services. Here we have the API gateway, entry point for all external API requests. It handles rate limiting, JWT validation, routing, and request authentication. All client API calls first hit the API gateway, where we enforce authentication using the JWT. The gateway checks the token structure, signature, expiration, and optionally consults the token revocation list or Keycloak introspection endpoint. After token issuance, the client makes a request to the gateway. The gateway then validates the token and forwards the request to the centralized IAM layer for advanced authorization checks such as resource level access decisions. Here we have the core of the authentication system, which is a centralized IAM layer. It reads claims like role, tenant ID, and scope from the token, then enforces access rules. Instead of embedding this logic in every service, we use this centralized layer to enforce consistent policy application, possibly powered by OPA, Open Policy Agent. Then we have service A and service B. Once the IAM layer verifies access, the request is routed to the correct service. For example, service A handles order creation while service B handles shipment tracking. Each service trusts the JWT claims and only handles business logic, not authentication. In cases where services needed to communicate, say order service needs status updates from tracking service, they use short-lived service tokens or mutual TLS and token forwarding. This internal traffic may be routed through a service mesh, example HTO, that enforces secure communication and observability. All data access flows through the services, never directly from the client. Services enforce tenant level isolation by including tenant IDs in their queries derived from the validated token claims. The system is a multi-tenant with each tenant having its own Keycloak RAM or scoped access. We implemented claim mapping in Keycloak to include custom data like department, project ID, or client classification. For scalability, we horizontally scale Keycloak, gateway, and IAM layer components. Services are stateless and auto-scalable with Kubernetes. Tokens are typically short-lived, 5 to 15 minutes, and refresh tokens are stored securely on the client.